Hi, this is the third part for 3.6 special segments in triangles. You're going to be finding special segments in diagrams. So the objective is how do we use the properties of special segments to decipher a diagram. So during your synchronous and asynchronous days, you were learning about special segments, identifying them, and applying them to find certain variables in the diagrams. Now, and plus with the diagrams, they told you what was what, so you were able to figure out based on the properties how to set up the equation to solve for the unknown variable. But in this case, there'll be times where they give you the diagram, they're not going to tell you what the special segment is, and you have to use the properties for the special segments in order to figure out which one's a perpendicular bisector, which one's the angle bisector, and so forth. So that's what this video will be talking about. So when it comes to identifying the special segments in the diagram, there is a process that will help you. So I'm going to write that out, use red now. So the first one, you would have to find the triangle. If they ask you to look for perpendicular bisector, you have to find that triangle where that segment is located. So the first process, oops, let me not move that, and let me redo that again. Get that red mark out and move this back to its spot. Okay, so the first one would be to find the triangle. And then the second would be to highlight. Highlight all the information that you need. Highlight given properties, info. I'll just put that. So basically, when you do that, then you'll be able to detect where the perpendicular bisector, angle bisector, and all that other stuff. So we're going to be working with this diagram in the next 4 slides, trying to decipher or find the special segments that we learned about. So the first one, which I will use blue, is they want us to find the perpendicular bisector. So when it comes to that, we have to look for 2 congruent segments and a 90-degree marker. So those are the 2 things we need to look for when it comes to looking for a perpendicular bisector. So we see the 90-degree marker here, and there's another one here. Now, which one do we choose? If I were to look at this one, I notice that there's 2 congruent segments, and then with that, the 90-degree marker. So right away, I'm going to find the triangle where all that information is, and I'm going to highlight that in blue. So I have this triangle, and that triangle. That line. And then go back to blue. And I notice that, okay, 2 equal segments, 2 congruent segments, and the 90-degree marker right here. So that means this is my perpendicular bisector. Because the properties for it is that there's a 2 congruent segments and a 90-degree marker. This has 2 congruent segments, but there's no 90-degree marker there, so this fits the bill. So then I'm going to put that GM is congruent to HM. And then I'm going to put angle LMH is 90 degrees. So I got those 2. So now that I know that my perpendicular bisector is line ML because of the 90 degree and the 2 congruent segments. Alright, the next special segment, angle bisector, and I'm going to use green for that. So what to look for with an angle bisector? Remember, bisector means cut something in half, but now it's cutting the angle in half, so we're looking for 2 congruent angles. So now we're going to have to look for a marker that shows two congruent angles. I only see this and this marker. So that means I'm going to highlight the triangle. So this one, because we have this angle part and then we have this side. So this whole triangle is being, the triangle's angle, the vertex is being bisected by this line, which is HJ. I'm going to use green for that. So see this ray? That is our angle bisector. So that means angle GHJ is congruent to angle IHJ. And our angle bisector, I'm going to put ray HJ. And that's all we look for. Okay, the next one is median. I don't know if yellow will show up, but I will try it anyway. If not, I will change to purple. So when you need to find the median, you're looking just for two congruent segments. I know when we were doing the perpendicular bisector, it says two congruent segments, but what makes it different from median is that in addition to the two congruent segments, you need a 90-degree marker with it. In this case, median, it's just two congruent segments. So if you were to look at this and this, we can't use it because there's that 90-degree marker, so this one is a perpendicular bisector. But if we look at this and this, these two congruent segments, so I'm going to put here HK is congruent to angle IK. I can clearly see that this line that goes from the vertex to K, the midpoint of that segment, is the median. I'm going to highlight that triangle in yellow. And then I could say, I'm not going to write that in yellow, I'm just going to put the median is, I put that in purple, is segment GK. Because it starts from the vertex and it goes opposite, goes to the opposite side to the midpoint of that opposite segment and creates two congruent segments. So don't get confused with perpendicular bisector and median. Median, two congruent segments. Perpendicular bisector, two congruent segments, and a 90-degree marker. And the last is altitude. So what we look for is a 90-degree marker, 90-degree angle marker. So basically, and another thing I should say, I should put here is the height. Because altitude means height, and that means it's going to be vertical. Because again, when we did perpendicular bisector, it said 90-degree marker, but that's in addition to the two congruent segments. For altitude, it's just 90-degree marker. So we see two of them. We see this, and then we see that angle marker here. But the thing is, one of them has to start from the top of the triangle and go straight down to the opposite side. So this would fit the bill. And if I were to highlight the triangle that we are working with, I'll use that color. So it would be, actually, I can highlight the whole triangle instead of that little piece. It could be that little piece or the whole triangle. Let me go back to that again. Could take this whole triangle because of the right angle. Now we can say that the altitude of that triangle will be this part that I'm highlighting. So that is segment NI or IN based on where you start. And a thing to remember about altitudes in a triangle It could be inside or outside the triangle. So in this case, the triangle that we're looking at, it is on the outside because the actual triangle is HIG. That's the original triangle. Notice the line that is extended from H to N. There's a dashed line. That means we extended the base, so that way we could find the height of the triangle. The slanted part is not the height of the triangle. It's a vertical part. And a hint, look for dotted lines. So look for dotted lines. Dotted or dashed lines, whichever you see. So once you see a dashed line extending from the base of a triangle, you know that there's going to be an altitude created from the vertex, top of the triangle, and vertically go down to that dotted line. Alright, so we deciphered this triangle. We found the perpendicular bisector, so I'm just going to go back. We found the perpendicular bisector because there's two congruent segments that were created and a 90-degree marker. And then we found the angle bisector. It cuts an angle in half, two congruent angles, and we found it. And the median creates two congruent segments. It starts at the vertex of a triangle and goes to the opposite side of the opposite side, where it hits the midpoint of that segment. And altitude is basically the height of the triangle. It could be outside or inside. If it's outside the triangle, then look for dashed lines that intersects with it, and then you find your height. And perpendicular bisector again has two congruent segments and a 90-degree marker. It has both, but don't get it confused with altitude, where it has just a 90-degree marker you're looking for, and the median, which only has two congruent segments. Alright, so that is a whole wrap-up of what you've learned about special segments and trying to find it in a diagram. Alright, so this ends our little segment. Have a good day.